that market size, that's about a $300 billion gap with a B. And it takes days to weeks to get it. And every hour that you don't have that's about $2 million lost. Factory in a box, material goes in, full product comes out. A customer, so they can actually design, iterate, and then off a machine make a full wafer of these things every few hours, test them out, and have real tangible results. That fixes your on-the-site needs. Amazon showed here's one platform that does the retail, and here it is on all these different genres of books. We're saying here's one platform that does all the printing, and here it is between your metals versus plastics, flexibles, carbon fibers. When times are tough, manufacturing does fantastic. When times are good, we do good.
Welcome to Space Terminal, the show where we sit down with founders defining the next frontier of infrastructure. Today, I'm joined by Ethan Baehrend, founder of Creative 3D Technologies. They produce factories in a box for batch manufacturing. Our listeners are leaders, operators, officers, and partners building emerging technologies. Ethan, welcome to the show. What is Creative 3D and what exactly is a factory in a box?
Well, first of all, thank you for having me on. Pleasure to be on and talk about deep tech. Well, some people might be familiar with what's called single cell manufacturing. Basically, on a production line, they're all considered cells. Whether it's a machine that's bending metal, punching a hole in it, or guy assembly, it's kind of like going from production cell to cell to cell on a line to make a product. Or from station to station could be another consideration. And our philosophy is that there's so many stations that are unnecessarily separated that don't need to be. We're at a stage in time where you can combine some of these typically separated processes, make a part for less time, less capital, more efficiently, less waste. And our goal is to do as many different types of production functions as we can in a single machine and hopefully get to the eventuality of, factory in a box. Material goes in, full product comes out, and we're going market to market with different techs.
Post-COVID, there was a seismic shift in demand from recreational 3D printing to industrial adoption. What catalyzed this shift?
The markets never really had the right perception necessarily from the start. I think early, like if we're talking that 2012 through 14 period, patents are first dropping, first units are coming out, all the articles were saying, this is your Star Trek replicator. This is a machine that you're going to be able to work with. It's going to be in everyone's house. It's a consumer product. I think that worked in a couple ways, actually. I think until we're at the point where the everyday person has a technical literacy to 3D model something just as easily as they'd type, make a PowerPoint, make an Excel, and just click print. They're not going to be able to click print on whatever is specifically in your mind. Yes, you can Google some things, you can edit it, you want your name on the docs, whatever else. And so until it's common sense that skill's common, I don't think it'll be consumer tech, or until we reach a point where there's a big player like an Amazon, for example, that has, hey, here's all the things you can buy, click to produce, and then using our partner machine, it can just make the whole thing end to end. And so there was a big shift. Well, it was kind of three events in one. It was your pandemic, the recession, the supply chain crisis all at once. And there's always been a large industrial use case for the tech. That's where it started. But there's definitely more people realizing that the need, the capabilities, and as we've started to shift focus from offshore production to trying to onshore what we can, people are looking at new techs instead of the antiquated ones. So.
As you mentioned, supply chain disruptions. Is there still dissonance in 2026?
You mean like are there still supply issues? Are the issues still there? Absolutely. And look at the RAM prices as a perfect example. It's another chip shortage, and it's a different chip. It's not GPUs this time, but there's still a massive shortage, and the iteration cycle takes an extreme amount of time. And now that the demand's being all taken up and the initial weighing budgets have changed for what these producers are outputting, the shift is going to take years. So this could be a longer term, several year cycle. And a lot of the issue, in my opinion, why we pursue is because of the centralized manufacturing model. The fact of the matter is, you go from machine to machine to machine to machine, and a lot of these machines haven't really been innovated upon in decades. It's been 3 to 5 decades since we've seen real major changes. It's a lot of iteration, good iteration by all means, that have, improved it, make it bigger, make it faster, a little more efficient. And the powers that were hungry at the time, that were focused on that, they bought it all up. These machines didn't change year over year. They kept buying and buying and buying and amassing quite the arsenal of machinery. And if any country wants to be competitive with that and get to the cost of goods sold of some of these products, you basically need to build out a similar arsenal in a couple years instead of the decades these other superpower ones built out. So it's hard to justify the cost of older tech. And in such a fragmented niche market, it's hard for, I say hard for innovation to flourish, but it's hard to innovate within it. It is hard to go on, start new tech, make the technology and get it out there. And it's a little discouraging because you kind of see all the fragmentation. You see, this is probably just the established way. Not many people challenge that. It's kind of a niche industry, and so people stay in their nice non-competitive niches. So in my opinion, what needs a change to do all that is you need a decentralized production. You need other facilities to be able to produce at least similar cost of goods sold as some of the offshores. And that's when you'll start to see those holes get patched, because if it's like, okay, our Taiwan facility is overrun and we can't, meet supply there, but, we got a U.S. facility, of a Mexico facility, wherever else it is, they can fill those supply gaps. Or if you can even start to do it on site where the product's needed with tech like some of the stuff we're hoping to pursue, then we think that's where the easy solution is.
In a world where your competitors are iterating, Creative 3D is innovating. You made the first ball screws designed specifically for 3D printing. Why did standard components fail?
I think some of it almost has to do with engineering principle. It is very much, if you go to engineering school, you're not being taught what to make, but you're being taught how to make it. Here's what shapes you can design on X and Y software, and you're going to use this and this type of machine to produce those shapes. Now go out into the workforce. And when people were, I think, making the initial 3D printers, it was which is understandable, it's all hackers and that, but it was a lot of very much off-the-shelf components. The complex stuff, like the hot ends or the things that are specific for 3D printing, yes, so those would be custom, but they saw, oh, well, if we can move a CNC with these linear guides, these ball screws, these motors, these belts, and let's use those. And the reality is that because the weight distribution's different, the vibrations are different, the heat's different, everything's a different environment than what those parts were initially refined for over decades. Similar, but different. You're not getting the full capability of what that part is advertised to do. And when you don't build to the function, you see the results. And that's why so many issues that people see on one machine are proliferated to all the machines, because they all follow that same approach. There was a big shootout at the beginning of the industry. What designs are going to work? What designs are going to fail? And then once they knew, okay, let's just keep doing that. Let's keep iterating on that. Let's make it bigger for this customer. Let's make it faster for this customer, hotter for this customer. They move to that trickle down fragmentation. And so, when we approached it, we were really looking at just trying to make a machine that worked a lot better. That's what we see as one of the biggest issues in manufacturing. And we started boiling it down to its core of, well, if these parts are the issue, then what's the right way to do this? And turns out it wasn't the standard route. That's why I was designing things from scratch, changing, okay, well, what about these little rails? How do they work? And it turns out there's like microns of stuttering. Then, okay, we need to do this to fix it. And got some creative solutions that turned out were applicable to so many other types of production. And that's where kind of built the ethos of the company, where we step back and realize, well, oh, we're faster than some high speed. We're larger into large, higher temp than the high temp, more precise, everything than all the specialty machines. Why make it just do one if you can do multiple and better serve people?
So, your market entry product, Evo, eliminates 90% of waste and precipitously reduces the cost per gram by 30%. How?
It kind of depends on the method, because it's almost two questions there. A lot of other machines where you have like a big vat of powder and you have a laser blasting at it, about 50 to 90% of the material that's unused to make the part in this big three-dimensional volume is waste. And in favor, we only extrude out what we use. At most, there's, Meyer scaffolding or something that you'll need to do. But, because we're able to get our cells at different angles, because we're able to mess with different layer structures, mess around with different widths of how much plastic or material or metal or whatever it is that we're laying down, the widths and the sizes, it changes a bit because most 3D printers are one consistent size. This one tool does the whole job in this method, this process, and there's a lot of inefficiencies there.
Creative 3D, you've alluded in a previous feature, competes on lower cost per final product, not over cost per part. Can you square this accounting for me?
When our goal is hybrid manufacturing, multiple of those functions, or true single cell production, the way that we see it is that for something simple like a plastic cup, we're not going to be more efficient than, a mass production facility offshore. It is a simple one stamp and done and it's off. We can't beat that, but that's not the goal. For example, you need this one part very specifically that would otherwise be a super easy stamp out, but you can't inventory it, and it takes days to weeks to get it, and every hour that you don't have that's about $2 million lost. There's a massive lost opportunity cost there. And so where we're effective is when we can shorten that time frame to produce that part on site, or if the part's more complex. If you would need to move for more and more machines, and depending how many of those functions that we can do on one machine, we can start to go from being more expensive to evening that out, if not being even sometimes cheaper. We have a lot of tools that we've not basically the different tools you equip this machine with are the different functions you can do. And we've played around with a couple tools and did self-healing robotic systems. So we had the printing side, we did basic smoothing using a really light kind of router mill. We did a couple little silvering tracing. We did so many steps so it otherwise make this thing a large 20 plus part assembly, and did it in one. And because we eliminated all those parts, the tooling for all those machines, the power to run all those machines, the waste generated by those machines, the shipping, distribution, everything else, we were cheaper than standardized manufacturing. So that's kind of comparison. The more complex or the more things we can do in one versus the more machines it takes someone else, the more competitive we're going to be.
Can you expand into the self-healing robotics technology, and what does that serve for your end user?
Actually, we had a local friend here that was doing something similar, and that's where we first found inspiration, and we found actual government call for it. So there's limited amount that can go into it. It's basically the idea that there's almost like a nervous system like structure within this thing that you line with a conductive material that is reactive to damage. It can then repair it, foam up, and kind of fill in the crack or damage there. Can't fix all things, but being able to do that for a decent few things helps quite a bit. But that's a completely enclosed structure that, if you're cutting away or molding material you'd never be able to make, that uniquely this technology is dispositioned to do.
Are technologies like this limited to special order projects, for example, the government, or is there a mass market for this?
It's definitely diverse. I mean, even our customer base, I think, reflects that, as we do have people starting Etsy shops and startups in their garages that are using these when they realize they want to have something a little more capable than what you can find on like the consumer market. And then we'll see that all the way up to your Fortune 500s and government contractors as well. I think it's diverse. It's definitely a step up from the user experience that you would expect for something like kind of consumer grade. It's usable enough that with a little bit of training on it that you can be running very well on this and innovating and iterating quite quickly. So it's exciting to see it enable a lot of folks in that manner.
The first orbital 3D printer found market fit in low volume precision components. How does the orbital market compare to, say, medical printing, automotive OEMs, or semiconductor fabrication? Can you walk me through the market concentration and where you are allocating more focus?
It is very fragmented. What the traditional manufacturing markets dictate and what people are hoping 3D printing moves to is that hyper specialization. Like, okay, this machine does this material, which makes it good for, a medical customer. And then this machine does this material at this size, it makes it good for an automotive customer. And that's admittedly half the crux of the problem. And if you can standardize that so that it costs the same amount and you can do it just as good, if not better than the current specialty, then you should be doing it regardless. And that's what we do. We very much dictate it less in terms of specific function, but more in terms of product volume. If you're doing specialty part production that isn't super high run, but is really complex and might not even be producible in some production methods right now, or if you're doing prototyping, or if you're doing light production, medium output, anything that's before kind of mass production where you need high quantities off of a single unit per month, then we have pretty good fit to assist and kind of handhold in all those other sectors. So we focus on them. Then when we advertise, when we go to a trade show, we show as much as we can. We show costumes that appeals to all the film and prop studios, or we'll show hey, here's these metal parts that we've made and actually thrown on a drift car, and I trust my life behind that car. We show the automotive people, yes, you can make what you're looking for turnkey. We try to, have different things that we can demonstrate for each market to really show appeal.
What's the single biggest limitation preventing you from scaling to Foxconn level throughput? Or is that not the goal?
I would say it's not the goal. I think there's a major gap in light production than mass production. Mass production, like we talked about, it is a refined technology. It's had decades in market, but there's gaps. Like if we're talking about Foxconn or semiconductors specifically, there's a massive gap there. Like if you're a prime, big name company, you're trying to design a chip, you're spending millions in design, and then, at most or something really advanced, fine precision, leading edge, and you're talking about spending close to $1 billion in some reported cases for tape out before you get a real result. So, and if you're looking to make something before that process, if you're a prime contractor, you want to make your own chips in house. If you're a company that wants to, like, say you're like a Neuralink where you want to mess with different substrates and base materials, the large fabs won't want to do that. It's not worth it. There's a reason why we make FPGAs built to the function, because when you're only running at mass production quantities, it's more efficient, more effective, because you're making all the tooling and everything to run it. Everything below mass production is not well, if not in some cases at all, served.
Can you quantify the cost?
That market's size, that's about a $300 billion gap with a B. That's an over $300 billion entirely missing piece of critical industry infrastructure. It's just not there. What we're looking to do is demonstrate how using our core base technology helps us combine separate manufacturing methods. Yes, you can use it 3D printing, but switch a tool, then you can go on to subtractive, the opposite manufacturing. You can go on to spray coatings. We're actually showing how you can do an end-to-end semiconductor from a single system.
Who are the buyers of this FPGA technology? It's obviously not smartphones.
That would be there too. There's a lot of, there are a wide variety of semiconductors, some that are less precise than others. The majority of them are not your super fine 2 nanometer precisions that you'll hear about in the news. They are physically larger units, so like 50 nanometers and above. And you'll have those sizes in your LEDs. You'll have those sizes in your game controllers. You'll have them in just about anything electronic. And there's supply issues of all of them. There's supply issues, especially on the leading edge stuff too. But even at, greater precision, there's issues there too, but it's massive. And we see there's such a market potential that if we can make kind of a similar how to Pursuit's factory in a box, if we can really pursue the concept like a fab in a box and put that on site for customers, so they can actually design, iterate, and then, off a machine, make, a full wafer of these things every few hours and test them out and have real tangible results. That fixes your supply chain gaps. That fixes your on-the-site needs, your high-risk needs. That changes your in-house production, prototyping, everything. It decentralizes and distributes a lot of that production power while dropping, the whole cost of what would otherwise be building a fab. So we, at least for what we're hoping to do, we see market in most types of electronics and gaps in most of them as well. So not mass production. Like I said, I think the differentiation is production output, but given that there's not much else doing lower outputs, it's a pretty true blue ocean right now.
Base metals have spiked over 40% on average year on year. Has that shifted demand appetite into additive manufacturing?
Yes and no. Additive manufacturing is not good for mass production, and most products that are out there typically needs a mass level of output scale. We'll see it in airlines or in aircraft because those are low volume, and it's low enough volume that cost per part and the weight savings and benefit you get from that part outweigh the cost to produce. It also doesn't help when, I think it's close to 70% of that global supply for these materials are offshore on the Asian continent. And I think there's definitely there's an issue of where some of the resources are coming from that needs to be looked at if we really want to bring that on site. If we start to have more local source of that and a more local production, we can fill certain gaps.
There is a new emerging domain for advanced materials. For example, there has been a push to produce Z-blend, fiber optics in space, push to innovate lab materials. How easy or difficult is it to adjust, say, a factory in a box to using new materials?
That's where some of the benefits of this tech are. Like the thermoplastics industry is a great example of an industry that's always been innovating, and they've innovated to the point where they can't effectively process some of the materials that they're creating and need new production methods to do so. And if you're someone that's designing a new material, you're probably going to test all the different methods you can produce it with, because that's going to determine who you can sell it to, what products are going to be put in. And the more variety you have, the better. And so there's, I think, massive applications on new material science side because it gives you a diverse way to test that out. And we've seen some application on materials that otherwise wouldn't even be standardly producible that are producible with methods like these.
When you're designing your technology for harsh environments such as the Arctic defense or for radiation dense in space R&D, where do you cut corners?
I wouldn't say cut corners, but there are limitations. There are certain processes that our machine just doesn't do right now. Doesn't mean that it won't do it in the future. That's some of those problems, depending on what radiation level you need or what material you need to process to do that, won't be unlocked unless we work directly with the company to build a specific tool for that process because they have enough value and there's enough value to us to do that. For example, like a lot of semiconductors are, another off-the-shelf program dual function chip that are then after the whole process coded to begin with, versus if a process like ours, you would be able to build it and test it with some of these materials from the ground up instead of just doing a coding after. There's more advantage having a specialty product do something instead of having the general product try to do it and adapt to that special specificity.
Hypothetically, a lab buys your $50,000 unit. What's the recurring revenue play during that 5+ year replacement cycle?
We start at 25,000 as we found that to be a comfortable sweet spot with a lot of different customer types for our industrial machine. I don't believe in the philosophy that if you sell a printer, the money's in the ink. I think it works for paper printing, but I think these technology are different because if you do that, you as a machinery manufacturer are then competing with a $1 trillion+ thermoplastics industry that's been around for decades. We would rather partner with some of the material suppliers, refine them for our methods, and then refer customers to that. If you want to expand this tool from just additive to processing even like different types of additive, like if you want to pull in raw pellets instead of a processed plastic, different tool, slap on, plug in, buy from us. But that modularity, if you want to expand what your tool can do, you kind of come to us for the modules. In addition to that, there's some light levels of consumables. So like a lot of printing, they have you use different cleaning processes, priming processes before starting a job versus, we have them built into a lower cost, but reoccurring piece of hardware that you can instead get through us too. We've seen enough of demand for the units themselves that that's a comfortable enough market and strong enough margin for us to pursue that before starting to diverge in other areas.
As you scale from a 1 million ARR business to 100 million, how does your technology cycle evolve? And has your North Star metric been consistent throughout?
At least starting our pathway has been consistent. A lot of the team are very, a mix of optimistic or very pessimistic engineers, me included in that batch. We've definitely shifted goals a lot. And I am someone that likes to see something work before really pushing. And admittedly, I expected some things that we were pursuing not to actually work. And then when they have, it starts to shift your plans from there. The semiconductor side, that was new to us. We were used to picking up and dropping in chips for some other projects. We figured it might be relevant and got more than we bargained for, very thankfully. Any startup, it should always be a agile, ever-shifting target. Never silo and laser focus yourself so much that you're not open to other potential and possibilities. Our business is a very standardized product. We have tried to standardize the technology, the modularity and base system to make it a couple different platforms, some that are public, that are as capable as possible per their size. And then from there, make it so then as we as a company grow, you're not buying a whole new system from us unless your needs drastically change. You're just buying the tool. So think of this almost, if I were to give like a easy swallow analogy, think of it like you have this super modular base car that in seconds you can push a button that turns between a sports car versus a pickup truck versus whatever else. Very separate things that otherwise be separate vehicles, but we just hit the modular platform that can happen to do that easily. And so we try to standardize that, but focus on making tools that are going to be relevant to new market segments that unlock new types of manufacturing. Like the semi side, yes, you can produce chips, but you can also produce MEMS, you can produce microelectronics, sensors, you can do super tiny scale 3D printing with it, you can do coating, sprayings, polishing. That one function, and the tools to do that function open up for the whole range of tech that we have. So many more things you can produce. And, so it's a lot of plateaus and spikes, and those spikes are fueled by the new tools that can enable new production tech. And because we can use multiple of those modules and tools at the exact same time in the same process, it opens you up to making things that were probably not even on an option in the past.
You're famously a bastion of the Amazon strategy. Start deep and then scale broad. Where is Creative 3D on that curve?
We're still at the deep side. The analogy, and what I've said often, has been that, Amazon started with a company that built the back end that could do retail in dozens of different markets, but they chose books. And then from books expanded to CDs, movies, etc. Ours is similar. Our book equivalent was 3D printing, because we see it as an industry that has no real dedicated unicorns in it. 14 years later, it's still very much a Wild West. Leaders seem to shift every couple years, and we see it moving towards hyper specialty. Amazon showed here's one platform that does the retail, and here it is on all these different genres of books. We're saying here's one platform that does all the printing, and here it is between your metals versus plastics, flexibles, carbon fibers, whatever. And then from there, for us to go from books to CDs, if you want to do a different market, cut material, buy this module, slap it on, plug it in, same base tech to do the function. So we can expand through there. We haven't grown to other markets quite yet, because the semi side, we got more than we bargained for there. It's changing the plan a bit, because we were going to, from printing, the milling, the printing, the fab. This year is our semi year for us.
You, in a few previous features, you've alluded to being mortality driven. If your bioprinting extends your lifespan to 150, are you still working 120-hour weeks?
For my own health and sanity, I have shifted a little bit from those weeks. I take the philosophy of I try to come in at consistent time, and then I have a set of goals to work at. And if I, get them done early at the end of the day, because I realize then your battery's out. Any pushing after that, you're just depleting a depleted battery and kind of starting to break it a bit. From there, leave. I slept like an everyman cycle for 4 years to do that, which is 4 hours a night plus 2 30-minute naps mixed within a day to get that many productive hours, but it transparently sucked. So don't recommend it. You feel like you're narcoleptic for the first month, but once you're in it, you do have a lot of energy boosts after those naps. I have analyzed a lot of times where if I were to pass away today, would I regret the path I've taken? And I try to be very intentional and pursue pathways and goals that I would look back, say, I'm sad I didn't see it to fruition and completion, but I don't regret it. And I can say comfortably I'm at that point now. And if I were to extend that lifespan, then I think it's a good cause. I've had some success with some other business type items in the past. The end goal of what this tech can do for people, and just having that ability there, both from a humanitarian level, sustainability level, and futurist level, there's so much appeal to that I do think it's likely that if I were to have more strong usable years one way or another, that I would probably be pursuing similar ends.
What shapes your decision making when you're pursuing new pathways, such as semiconductors? What heuristics do you look at?
Sure. I do look at a lot. I try to stay up to date with, all the large research players that do give their market studies every quarter and their estimations on what they see coming in the future. Surround myself with people in a lot of different industries and markets that give me good perspectives on how the world's moving and what it looks like. But outside of that, there's a very human element. What your gut says and what you've seen, you start to build intuition of, is it actually going to move this way? Is this a fad? Why or why not? Is this a bubble? What's going to actually drive a positive end result? And I think it's a little easier to determine in manufacturing and hard tech. It's one of the reasons why I like the industry is it's very black and white. You can make the thing or you cannot. It works or it doesn't. And there's not a room for a gray area there. I like that as an engineer, because it does help me kind of shape my pathway. It's a pretty easy goal of just make the most capable thing possible. And when that's the company's goal of just, try to throw as many types of production as you can in one box, we can pursue every different direction, and there's going to be a market, because it's such a, like I was mentioning, it's such a focused one function, one machine type of market. There is room in most production to drive some level of benefit no matter where we decide to direct it. And we direct it where we see the tech and where we see the need. Like with the whole semi side, because we've seen those chip shortages, because we see the increased rise in price, because we see technologies like AI, we see all the capital backing the AI itself, but because it's all software capital, they're not asking them how much power does it take to run your AI. They just ask how much you pay in cloud credits. So you don't see this growing spike of AI running at a rate like this while chip production and the evolution of it's growing like this. There's, a hard technology driven crash that's going to happen if all the capital stays 95% in software than the hardware. And that's, what we've seen in a lot of markets. And that's why we had supply chain crises like this. It starts to shift that 95% concentration, at least in US investment, from software to start to blend into other markets to even them out, because there's a disparity between the two. So there's definitely a need, I think, for some market shifts, but overall, it's a clean way to have a pretty easy North Star to keep pursuing. And if you can touch on it, you have a technology that can benefit it, there's probably going to be good market opportunity there from our experience.
You've been invited to speak at the UN a few times now.
Yes.
What's the climate angle for on-demand or decentralized manufacturing that policymakers are missing?
There's a good few. I think there's a lot of assumptions on manufacturing, supplying the emissions, and then there's the reality of what the statistics look like. And I don't think that the policy maker is in line with that. So manufacturing, when it becomes more focused on higher output efficiency, not sustainability, that's where the clientele starts to come in. It's the exact same ethos of, if you can do 5 machines functions on one, you're going to pollute less, you're going to generate less waste material, you're going to consume less power to produce it. That is more green. If you want to use a more sustainable material, like we can use anything from like ocean plastics and turn them into furniture. And if you can do that on site, on demand, you start to eliminate the transportation emissions, which the global leader in pollution is energy and energy production. But number 2 and number 3, it's transportation, which is 60% supply chain. And so why fix the energy side and go for diminishing returns and try to be 1% better, 1% more efficient there, when for the same amount of capital, you can have a much larger percentage in CO2 emissions drop if you fix the actual problem in the machine. Fix how much power that machine's consuming to produce your part versus how you make that power. And I don't think, because it's a niche industry and not enough people innovate in machinery, I don't think that there's a focus on that, because, most of their money is pushing higher and higher outputs. So, the climate angle is in a couple layers there, and at least humanitarian angle that comes up in those same places as well is the effects of those supplies on a lot of rural communities. Like a lot of rural communities, the UN will, for example, provide water, solar, and internet connectivity to. But then in a couple of years, what happens when those things break down? They've already spent the budget to equip that community. And because they're the furthest from disconnected from traditional supply chain, it's kind of backwards that third world community we're supposed to be helping has to pay the most for offshore supplies. And our philosophy is, if we can get to the point of some of this tech that we can drop these on site, like if you have a water filtration system, which is a conversation we're having right now, actually, and we can drop our unit right next to it, and that thing goes bad, produce the part right there, fix it and keep it going without the supply, and even let them use that on off hours, let the community use that technology to innovate, iterate, and then be able to send that design off and start a company. Where you start to make hardware as easy to innovate in as software would be, and you connect them to supply by giving them their own production power. It's true. That's the one kind of missing piece in circular economy is production.
You have operated your business under multiple federal regimes and under 2 different states. From your vantage, entering 2026, how has the business environment evolved?
I like manufacturing for this reason. Pandemic, recession, supply chain crisis, these big world events, which have lasted several different management cycles. While those have negatively impacted 90+% of businesses, look at which ones actually had spikes during that time. When times are tough, manufacturing does fantastic. When times are good, we do good. It is a consistent need that isn't so saturated like other markets that there's risk to go down. 3D printing, there's always a need for it. And as long as you can meet that need as it keeps shifting and evolving, you're going to have a market niche. You're going to have a need. You're going to have a customer base. So at least for us, it's been fine. When I've been in Japan, when I've talked in Hong Kong, a lot of the Asian offshores, because when you open those newspapers, you will have manufacturing as a first on the headlines kind of market. But in the US, you don't. You've got AI, you've got data centers, you've got semiconductors, you don't have manufacturing. I think the US populace, even though we say, hey, we want to invest in manufacturing, the capital, they're not comfortable or familiar enough with it as a market to back it. And I think that's one of the disconnects with it. We see policy is trying to dictate and push people towards that.
Why do you believe there is this incongruence in American versus other sovereigns when it comes to manufacturing specifically, given that manufacturing is table stakes, whether it is Starship, whether it's the 2 nanometers semiconductors, or even drug production?
I always like to look at history. I like to look at how some of these markets have evolved. Manufacturing, for a while, was a very strong American market. Like if you look at a lot of things made in like the late 1800s, you'll see American-made stamps ever, and there is a level of pride within that. Earlier 1900s, you will start to see other countries start to adopt that in, and they see how much it's built the American economy at the time. So there is a hard push to adopt this, we innovate and iterate, and build that base. And it starts to drop the price compared to the American manufacturing. The American companies, if it's a lower bottom line, let's buy from the offshore. They keep buying and buying and buying more of the same machines until they have an arsenal that makes it so efficient for them to produce compared to doing it here. Build a corner. They built dependencies. When it's all final consumer driven, how much are they going to eventually pay for that end product or service, and somewhere else can produce it and get to you cheaper, a lot of people look there. We started to see that level of efficiency get brought into American businesses. Less people wanted those jobs because it's less talked about, because it's not as prevalent and prominent in that American society. And there are people that, go through school and saying, I really want to be in this manufacturing tech or this machinery designer or whatever. They find jobs quickly. And that's part of that shift. And I think now we're kind of realizing that we're behind the ball. People are trying to retroactively fix that, but it is a hard multi-layer issue. Like the American market knows semiconductors. They get it because they see the need. It is on their front pages. So the investor that might not know about how we make the semiconductor, but knows that's a big enough market, they'll back it. And so I think we need to start having more of those conversations in the US if we do want to start to see some of that shift.
And a few times in this conversation, you've alluded to technical know-how. Is there a limitation? Is there a real barrier to upskilling?
In terms of talent, I think there has been a shift, and I think we're starting to see it. I think a lot of people are starting to realize that different skills are needed, and a lot of articles talk about this. A rise, I think, in blue collar. Even we're at a point now where South Park's even joking around how they can't, fix an oven, how the handyman's making, 7 figures because it's, starting to be a neglected skill set. A lot of these high schools and even middle schools in some cases are starting to put 3D printers in their labs, get something they can really create with, because if you can foster that creativity, they're going to make something that's going to be pretty impactful. And when they know there's a job and there's a solid career path in there that's a little less turbulent, that's a good thing. That's why we try to work with our city to, Cedar Park, where we're with a lot of workforce development programs and building that out.
What should we look forward to from Creative 3D over the upcoming quarter?
There's a show called IMTS. It's the International Manufacturing Trade Show. It's exciting. It's a cool space to be. CES as well. 2026 is going to be eventful. We'll have ribbon cutting for our expanded facility where we will be pursuing the semiconductor tech and improvements to our production for the standard Evo systems and even potentially an Evo V2 that we'll be teasing soon enough. Our big goal is to actually show off a very interesting chip demo that I won't give much detail on within the year, and really prove and show that we have a single machine that can make an end-to-end wafer of chips. So that is the big one that'll come out this year, and we're excited to have that announcement when it's ready.
I'd also like to highlight your award from CES. Congratulations on that.
Thank you.
What an important feat. And how can prospects contact you or Creative 3D?
Sure. Yeah, we have a web form right on our website. Makes it easy to reach out to us if there's an interest in our unit. So, and we actually read it and go through it. So we'd be happy to chat with anyone.
This has been Space Terminal. I am Zuni from Imagining Forward. New episodes are out every week. You can find Ethan Baehrend and Creative 3D Technologies in the show notes. You can also look up Creative 3D Technologies on our intelligence tool at imaginingforward.space. Thank you for joining, Ethan. I really appreciate your candidness.
Thank you.